Good morning, students, and welcome to Q&I summer course. Am I audible to everyone, students? Please give me a thumbs up if I am audible to everyone. Okay. So let's start the class, students. So hello and good morning, good afternoon, everyone. So I am Sunit Kumar and I am your mathematics teacher. And so we are continuing with number system, uh, which we have started. So today, students will complete the exercise which we are doing from the NCERT, and then we'll do operations on real numbers. And if time permits, then we'll also start rationalization. So let's start the class, students. So as I said, we'll continue with the chapter number systems. Prerequisite for today's class is you should know about the number system, that is natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So you should know the properties of rational numbers and decimal representation of rational numbers. You should know irrational numbers, properties, and the decimal representation. And you should know about the real numbers. So as we know, real numbers is a combination of rational and irrational numbers. In today's class, students, we are going to continue with doing questions of real numbers and their decimal expansion. And then we'll do operations on real numbers. So let's start the class, students. So first of all, we have to express 0.99999 up to infinity in the form P by Q. Okay, so first part of the question, first let us convert it in the form P by Q. So for this, what we do is let x is equal to 0.99. So this is non-terminating and recurring decimal, which can be written as 0.9 bar. Okay, now we multiply by 10 on both the sides. So multiplying by 10 on both sides of the equation, we have 10x is equal to 9.999, so on. That is 9.9 bar. Okay. So this is your first equation, and second equation. Now what we'll do is subtracting 1 from 2. What do we get? 10x minus of x is equal to 9.9 bar minus 0.9 bar. So digits after decimal will get cancelled and you will have 9x is equal to 9, and this is going to give you x is equal to 9 by 9, which is equal to 1. So x is equal to 1. Now the second part. Are you surprised by your answer? Yes, here it is given that x is 0.9999 and so on. And what are we getting here is x is equal to 1. Now with your teachers and classmates, discuss why the answer makes sense. Who is going to tell me? Why this answer makes sense? Who is going to tell me? Anyone, please. Why did we get this? X is equal to 0.9999 up to infinity. Now this here at the end we are getting x is equal to 1. Anyone? Yes, Samagna is typing something. Anyone, please. You can unmute yourself and answer. Okay. So I'll tell you why it is like that. Is because see 0.9999 up to infinity, that is approximately, because this is very near to 1. So we can also say that x is equal to 1. Yes, Subhranshu, you are correct. That is another way of putting it. If 1 by 3 is 0.3333 up to infinity, then we can, when we multiply both numerator and denominator, if you multiply the numerator by 3, you will get 3 by 3, that is 1, that is 0.9999 and so on. So logically, if you think 0.99999 up to infinity, that is very close to 1 and that is almost equal to 1. or you can say it is equal to 1. That's why it is like that. Okay. So the answer is correct. We are not wrong. X is equal to 1 is the P by Q form of this 0.9999 up to infinity. Is this clear to everyone, students? Okay, let's move ahead. I hope everyone has written this down. Shall we move to the next one? Okay. Now the next question is, this requires a lot of calculation. So what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? So when you are dividing 1 by 17, what is the maximum number of repeating block of digits in decimal expansion? Can someone guess what can be the maximum number of digits here? No, Kavin, no, Kamalan. So maximum number of digits will be equal to, so maximum number of digits in the decimal expansion of 1 by 17 will be 17 minus 1, that is 16. Is it clear? Subhranshu, you were very close. So it is 17 minus 1, 16. Right? That would be the maximum number of digits. If you remember, 1 by 7 was 0.142857. If you remember. Do you remember this? 1 by 7. Now, there was denominator was 7. So maximum number of digits you can see here is 6. 7 minus 1, 6. Similarly, for 1 by 17, it will be 17 minus 1, 16. Now they are saying, perform the division to check your answer. So you have to do 16 times division to get the result. Let's do that. So because 1 is less than 17, I'll put a 0. So 10. Again a 0, we have 100. So we know that 17 times 5 is 85. So you have 15, 150. So 17 times 8, if you calculate, is 136, right? So we have 17 times 8 is 136. So you will have 14 here, 140. 17 times 8 is again 136. You will have 4 here, 40. So 17 times 2 is 34. You will have 16 here, 160. Sorry, 60. So 17 times 3 is 51. We have 9. 17 times 5 is 85. We have 5. And then we have 50. So 17 times 2 is 34. We have 16, 160. 17 times 9 is 153. So you have again 70, right? So 17 times 4 is 68. You have 20. 17 times 1 is 17. We have 3. I'll start with 3 again here, right? Because I don't have space. So I can write it, or I'll do one more. 17 times 1 is 17. So you have 13. So I'll put it here. We have 130, right? And then 130 and 17. So 17 times 7, right, is 119. So we have 11, right? 110. So 17 times 6 is 102. We have 80. 17 times 4 is 68. We have 120. 17 times 7 is 119. And then we have again 1. So now once we have got 1, we have reached back to the same place. So these are the digits which are repeating. If you count it, you will have 4 plus 4, 8 plus 4, 12 plus 4, 16 digits. So 1 over 17 is 0.058823. So 0.058823 529 411 7647, and this repeats. I have removed my image purposefully so that you can see the complete division here. Are you able to see the complete division, everyone? Quickly note this down. I am not there on the screen so that you can note this down. Okay. So this is the complete division which ends here with the same remainder as 1, which was the first remainder from where we started, 1 over 17. And then you have this. Has everyone written this down, students? Please note this down. Okay. If everyone has noted this down, we can move to the next one now. Shall we move to the next one? Okay. Now the next question is, look at several examples of rational numbers in the form p by q, where p and q are integers with no common factor other than 1 and having terminating decimal representations. Can you guess what property of q must satisfy? So look at several examples of rational numbers in the form p by q, where p and q are integers with no common factors, means p and q should be co-primes. They should have no common factor other than 1 and having terminating decimal representation. So if you see this, 2 by 5, 2 by 5 is 0.4. Now 2 and 5 are integers, but there is no common factor there other than 1, right? And this is equal to 0.4, which is terminating. Another example, let us take 3 by 8. Now 3 by 8, if you calculate, we know that 3 and 8 have no common factors, right? So 3 by 8 is 0.375. This again is a terminating decimal representation. Now another one, let us take one more. So let's say we take 6 over 10 or not 6 over 10, 9 over 10. So 9 and 10, they don't have any common factor, and 9 by 10 is 0.9, which is again terminating. Now, if you see the pattern here, you know, the property of Q. So Q is the denominator. So here Q was 5 raised to the power 1. In this case, Q is 2 to the power 3. In this case, Q is 2 to the power 1 into 5 to the power 1. Right? Now, in each of these cases, what are you noting here? That the Q must satisfy Q should be of the form 2 raised to the power n into 5 raised to the power m, where n and m are whole numbers. That means that prime factorization of Q has only powers of 2 or powers of 5 or both. Okay. So 2 should have, powers of 2, powers of 5 or powers of both 2 and 5. So here you can see only power of 5. Here in the second case, only power of 2. And in third case, power of 2 and 5 both. So if your denominator in any P by Q form rational number, if the denominator has a prime factorization of only 2, only 5 or 2 or 5 both, then we say that this rational number has a terminating decimal expansion. Is this clear, everyone? Have you understood the concept, everyone? Quickly note this down. Why? Because this is the basis of the last exercise of your class 10th syllabus, not in 9th, but class 10th. But there is one question which is there in NCERT which focuses on this concept. Please note this down. Has everyone noted this down, students? Okay. Let's move to the next question then. The next question is, write 3 numbers whose decimal expansion are non-terminating and non-recurring. Any 3 numbers whose decimal expansion are non-terminating and non-recurring. So the numbers whose decimal expansion are non-terminating and non-recurring is root 2, root 3, pi, root 5, and so on. Right? Is it clear? It is non-terminating and non-recurring. Because these are irrational numbers. So irrational numbers, the decimal expansion will be non-terminating and non-recurring. Clear? Shall we move to the next one now?
Sir, can you repeat?
So the question was, write 3 numbers whose decimal expansion are non-terminating and non-recurring. We know that decimal expansion of irrational numbers. So decimal expansion of irrational numbers are non-terminating and non-recurring. Okay. So root 2 is an irrational number, root 3 is an irrational number, pi is an irrational number, root 5 is an irrational number. So these are examples of 3 numbers whose decimal expansion are non-terminating and non-recurring.
Okay, sir.
Shall we move to the next one now? Now the next question is, find 3 different irrational numbers between rational numbers 5 by 7 and 9 by 11. Okay. So first of all, we need to find out the value of 5 by 7 in decimal, and similarly 9 by 11 in decimal. Okay. So we know that 5 by 7 is equal to 0.714285, and this is non-terminating and recurring. Okay, there will be a bar over 714285. 9 by 11, this can be written as 0.81, 81, 81, and so on, which is 0.81 bar. Is it clear? This we had seen last time. 1 by 7 was equal to 0.142857. And we saw that, if we have to find 5 by 7, we'll multiply this by 5. This is one way of doing it. And then other was when we saw the, repetition in the remainder, then also we could have guessed the values. Similarly, 1 by 11 is 0.0909 and so on. That is 0.09 in bar. Now this was again, if I have to find 9 by 11, I'll multiply this by 9. I'll get 0.818181 and so on. That is 0.81 bar. Now we have to find three different irrational number between these two. Between 0.714285 bar and 0.81 bar. So we can have numbers as 0.72, 1, 0, 0, 1, 000, 1, 4 times 0, and so on. So this is non-terminating and non-recurring. So because we have to find irrational numbers, we'll find three non-terminating, non-recurring decimals between 0.14285 bar and 0.81 bar. So this is first one. Second one will be same, 0.73, 100, 100, 1 4 times 0, and so on. And similarly, you can have 0.74, 100, 100, 1 4 times 0, and so on. Is it clear? Is this clear, students? Have you understood the concept? How to write three irrational numbers between rational numbers 5 first, and then 9 by 11 to decimal form, and then we'll write three irrational numbers between these two rational numbers. Please note this down, students. Have you understood this? Everyone, have you understood the concept here? We convert 5 by 7 and 9 by 11 into decimal form and then write three non-terminating, non-recurring decimal lying between these two. So we'll get three different irrational numbers between these two rational numbers. Is this clear? If it is clear, please give me a thumbs up, or you can write it in the chat or unmute and tell me. Okay. So let's move to the next one then. So next question is, classify the following numbers as rational or irrational. One by one, you need to tell me. First one, root 23, whether it is rational or irrational. Root 23. What is it? Rational or irrational? Irrational. Correct, Aditi. Because square root of all prime numbers are irrational. Square root of any prime number will always be irrational. Okay. Next, second, square root of 225. Whether it is rational or irrational. Second one,
Rational, sir.
rational. Why? What is the value of root 225? Value of root
15.
225? 15. It is a perfect square. So when you take a square root of 225, this is 15. So since it is 15, which is an integer, it will be a rational number. So first one was irrational. Second one is rational. What about the third one? It is a terminating decimal. That means it is, what is the third one? Terminating decimal. It is rational. Okay. Terminating decimal is always rational. Now we have 7.478, 478 and so on. So this is non-terminating and recurring decimal. So non-terminating and recurring is also rational. Right? Now fifth one is 1.10, 100, 100, and so on. This is non-terminating and non-recurring. So non-terminating and non-recurring will be irrational. So fifth one is irrational. Very good. Is this clear to everyone?
Yes, sir.
Let's move to the next one now. I hope everyone has written this. So terminating decimal and non-terminating and recurring decimals are rational. Non-terminating and non-recurring decimal will always be irrational. Now we'll start with operations on real numbers. Okay. So the sum or difference of a rational number and an irrational is irrational. Means if we have something like this, rational plus irrational, this is always irrational. Now rational minus of irrational. So when I say sum or difference, both will always be irrational. Okay. That means, let's say we have a rational 2 plus root 3. This will be irrational. Similarly, root 5 minus 3. This again will be irrational. Why? Because you are doing sum of a rational and irrational will be irrational. Similarly, some difference of irrational with a rational number will also be an irrational number. Correct? Next, the product or quotient of a non-zero rational number with an irrational number is irrational. Okay? So product or quotient of non-zero rational number. So you multiply rational with irrational. This will also be irrational only. So for example, if we have 5 root 3, so 5 is rational, root 3 is irrational, 5 root 3 will always be irrational. Third one is if we add, subtract, multiply or divide. So before we go to this, when we say product, we have already seen the quotient. Quotient means rational divided by irrational is always irrational. So if we have root 3 divided by 5 or 6 divided by root 7, these are all irrational numbers. Clear? Now next one is if we add, subtract, multiply or divide two irrational, the result may be rational or irrational. Means, if we add root 3 plus root 5, now this will be irrational. But if you have root 3 minus root 3, this is cancelling and getting an answer 0. So this is rational. So it may be rational or irrational. If it cancels out, that means it is rational. It will give you a rational value. Similarly, if we have root 3 divided by 2 root 3, root 3 gets cancelled, you have 1 by 2, which is rational. So again, for addition, subtraction, multiplication or division, so if you have root 3 into 5 root 3, we know that root 3 into 5 root 3 will be 15. Now this again is rational. So multiplying two irrational numbers or dividing two irrational numbers, adding or subtracting two irrational numbers may give you a rational number as an answer or irrational number. Is this clear, students? Please quickly note this down. So when you have sum or difference of rational and irrational, the result will be irrational. When you have product and quotient of rational and irrational, the result will be irrational. But if we add, subtract, multiply or divide two irrational numbers, the answer can be a rational number or an irrational number. Clear? Is this clear to everyone? Please give me a thumbs up if it is clear to everyone. Good. Let's move to the next one now. Now in this question, check whether 7 root 5, 7 by root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. We know that a product of rational and irrational will be irrational. So the reason you will say that product of rational and irrational is irrational, that's why. Similarly, the quotient of rational and irrational, this will also be irrational. A number rational added to irrational will give you irrational, and irrational and rational, the difference here will again be irrational. Is this clear? The product of rational and irrational is irrational. The quotient of rational and irrational is irrational. The sum of rational and irrational is irrational. And the difference of rational and irrational is again an irrational number. Is this clear, students?
Yes, sir.
Okay. So students, I'll quickly, open the platform and will take you to the practice session so that, I'll give you the homework which you have to practice today on the platform. So when you log in, students, you have to go to assessment, practice and custom. Here in the practice session, I'll have to log in again. Just a second. So when you log in, student, you will go to assessment, practice and custom practice. Here in mathematics, we'll look for number system. We'll view the topics here, and in the topics, so deduce decimal form of real number to classify them. This is the homework for today. Okay. Deduce decimal form. So you can check it here, students. Deduce decimal form of real numbers to classify them. This is the topic which you need to practice today. How many students are able to log in on the platform and practice? Are all of you able to practice there? Okay, Hannah can do that. Hannah, yeah, you have a doubt? Kamalan, what is the issue you are facing on the platform?
Like I can't open.
Could you take the diagnostic test on that day, Friday?
What, sir?
Could you take the diagnostic test on Friday, proficiency diagnostic test?
No,
Which
sir.
we can.
I have to take it.
Okay,
No,
do you have?
I didn't. Because I can't open my platform, so I couldn't.
You couldn't. Okay. So, what I'll do, I'll ask my team here. They'll connect with you, the customer engagement team. They'll connect with you and we'll try to enable everything for you. Okay.
Yes, sir.
Okay. Okay, everyone. Thank you. Thanks for joining in. So again, we'll meet in the next class tomorrow. Bye and take care.